All right. This is me just teaching by myself and not in class because I had some technical difficulties yesterday in class with my computer and stuff. So I think I got it ironed out. So I'm just going to reteach the lesson. So if anybody needs to look at it, you can do that. So let's get started. So the thing we're going to talk about today is a number line. So let's take a look at this. This is a number line. And just a couple things about the number line. Um, we can put some marks in here. Talk about those in just a second. A couple more. There we go. Okay, so it has arrows. The number line has arrows to the left and to the right. So if we go to the right, we're going in a positive direction. That's just how we determine. It's how mathematicians determine. Positive if we go to the right. If we go to the left, it's negative. That's just a convention that mathematicians figured out. So that's what that means. Okay, the arrows mean it goes on for infinity. It keeps on going forever and ever. That's what the arrows indicate. So on this number line are points, and sometimes we designate, we put lines here so we can figure out where the points are and that kind of stuff, and we try to keep them evenly placed. A lot of times you'll see the zero right in the middle. It doesn't always have to be in the middle, but that little pink thing was, but anyway, there we go. So to the right of zero, anything to the right of zero is positive, anything to the left of zero is negative. So I just put a 1, 2, and 3. These aren't the only numbers on the number line. Okay, they're just ones that we designate because we think they're pretty important. So we can go in the other direction. So this would be -1, -2, -3. This is all basic stuff. This really technically isn't college algebra, but it's just review of the number line. So let's do this. Let's try another color. Let's make it yellow. And let's put a dot right on one of these numbers. Okay, so this is where our point is located. So when we talk about where a point is located, we're talking about the coordinate of that point. Okay, so where is it located? So these are kind of an indication, these numbers are an indication of where the point is on the number line. And so it would be at +2. So this point right here would be at +2. A lot of times you would see a capital letter associated with a point. Sometimes they don't have any numbers here at all. They just put capital letters here and you say this is point A, this is point B, and so forth. But most of the time you'll see numbers here on the number line. All right, so that's the first thing, that's the coordinate. So let's talk about a few things with this coordinate. Oops, going the wrong way here. Let's try this. There we go. Let's slide that up. Let's put that number line back here again. And let's talk about a couple other things with this number line. Let's change colors. Let's go to this pink color. All right, let's, we got the arrows there. And what if I put a point? It's a little sloppy, a straight line. There we go. Straight line right there. And let's just say that this is A and this is B. So this isn't technically point A. This just means this represents a number on the number line. We just don't know what it is. And this represents a number on the number line. Again, we just don't know what it is. So what we're doing right here, again, is really basic and really simple. But anything to the left of another number is always less than that number. So that means that that means that in this particular case, A is going to be less than B. All right, remember the less than, greater than symbols, that is less than. So A is less than B. This could be a B and this could be an A, and we would say that B is less than A, right, if we wanted to do that. Let's do another one. Let's put the number line on here again. All right, again, this is really basic stuff. Let me go back to that color again. And let's just put a line right here. You wouldn't see this very often, but if you put an A here and a B right there, that means we're talking about that same exact point. So that's point A and it's point B. Well, it's at the same exact point, so what do you think is true about A and B? Sure, they're going to be equal to each other. So A is equal to B. All right, that's pretty simple. Keep that right there. And let's put another number line. And let's grab my color again. All right, so let's do this. We already talked about this actually a second ago, but what if I put a B here and an A here? Just because A comes before B in the alphabet doesn't mean that A is always less than B. It's where it's located on the number line. So B is to the left of A, so B must be less than A. We could also say this. We could also read it from right to left. What if we read this from right to left? Instead of going from left to right and saying, let's compare B to A, let's do this. Let's compare A to B. So what is A compared to B? So I put an A here and a B here. What is A in this particular situation? What is A compared to B? Well, it would be greater than. These two things right here are the same exact thing. Okay, B being less than A, you could read it from right to left. You could say that A is greater than B. It means the exact same thing. So let's just do a couple examples. These are really simple examples. Let's just do a comparison. That's all we're doing. So let's take a 3 and a 7, for example. So let's compare with our inequalities. That's what that less than and greater thing is. It's called an inequality because they're not equal to each other. Or they could be equal to each other, okay? So inequality or equality. We want to stick something in between here that makes this true, going from left to right. So I say 3. Well, 3 is a smaller number than 7, so 3 is less than 7, so that's our inequality. Pretty easy. This is like elementary school stuff. Now this right here is not necessarily elementary school stuff because we introduced the negatives, but let's take a look at this. Where is negative 8 compared to negative 16? Well, if you drew a number line, you can just do that in your head. If you drew a number line, negative 8 is closer to 0. Negative 16 is further away from 0 than negative 8 is. So that means that negative 8 has to be greater than negative 16. For people that don't understand negatives, they would look at this and they say, well, 16 is bigger than 8. So 16 must be greater than 8. Well, they're not positives, they're negatives, so things change. All right, so negative 8 is greater because it's closer to 0. It's more to the right. Negative 8 is more to the right of negative 16 if I drew a number line and I put the numbers on there. Okay, let's try just a couple more. Let's try negative 6 and 0. So we're comparing negative 6 to 0. Which one is bigger, which one's smaller, or are they equal to each other? So negative 6 is where on the number line compared to 0? It's to the left of 0, so that means it is less than 0. Pretty easy. Let's just do one more. Let's do this one, 4 and negative 1. All right, so 4, compare it to negative 1. Well, 4 is a positive number. Negative 1 is a negative number. So positive numbers are always bigger than negative numbers. So 4 is greater than negative 1. Pretty simple. So to sum all that up, if we say this, if we say a number, any number, that's what the A represents. If any number is greater than 0, then A is always positive. I'll just put a plus sign here, okay? So if a number is bigger than 0, that number, A, has to be positive. I'm going to hear an announcement here, so bear with me.
If a student wants a Gatorade water bottle and your parents' car, please stop by the office to pick it up. Thank you.
So I'm sitting in my classroom. This is actually Thursday morning before I go to college algebra class. All right, so it's A. What if A is less than 0? Then A must be what? A is, instead of positive, if it's less than 0, A must be negative. You could write the word negative in here if you wanted to. All right, well, enough of that. Let's take these same principles and talk about them just a little bit further. What we're going to do is we're going to actually graph some things. Let's try different colors. Go blue this time. All right, so what we're going to do is we're going to graph just making sure it's recording. Okay, so we're going to graph x is not equal to a number. If it was equal to, we would just find that number on the number line, just put a dot there. But what we're going to do is we're going to find all the numbers that are greater than 4. Now, there's a lot of numbers that are greater than 4. You know, if I ask somebody, give me a number that's greater than 4, a lot of people would just say 5. 5 is greater than 4. That's true. But we wouldn't just put a dot at 5 and that's it. We want to find all the numbers that are greater than 4. So what I'm going to do, let's put the little dashes in white. So, and we don't always have to have a 0 in there, because if you have to graph like a positive, 73, you don't want a 0 in there and have to put 73 marks to get to 73. So what I'm going to do, greater than 4, so I'm going to actually I'll just do a handful of them. I don't have to have a ton. I'm going to put a 3, a 4, 5, because I'm going greater than, so that must mean I'm going to the right. So I'll put a few points in here like this. Okay, now let's go back to the blue. And so what I want to do is I want to find all the numbers that are bigger than 4. Well, do I put a dot at 4? This is not x is equal to 4, so I do not put a dot at 4. It's all the numbers that are greater than 4. So I want to find what's the closest number to the right of 4 that's bigger than 4. Well, there really isn't any. There's really an infinite number of points in between 4 and 5. So I can't get right next to 4. You can put a 0.01, or you could put a 4.00100001. You get the idea, right? You could keep going. You could put an infinite number, infinitely close to 4. So in order to show that on our graph, what we're going to do is we're going to put a circle. That circle means it's really close to 4, but it's not 4. It's as close as you could possibly get to 4, but it's not equal to 4. And then what we're going to do is we're just kind of scribble in. All right, and you don't have to go all the way to the end. If you want to, you can. And then this. So that squiggle line right there, that means all the numbers. Since I put an arrow here, that also means all the numbers to the right of it. So it just keeps on going. I just don't want to make my arrow all the way to the end. That's it. All right, so that's how you graph x is greater than 4. So this means all the numbers that are just to the right of 4, as close to 4 as you could possibly get. So I put a circle here. I don't fill it in. If I filled it in, that means it would be equal to 4. So I don't want that. Okay, I just want all the numbers that are greater than 4. All right, so that's how you graph that. Let's do one more of these. This is called graphing inequalities, okay, because they're not necessarily equal to, except this one. This one's got a little bit of equal to it. And what number do I put? I put 5. Let's try that 5 again. It's kind of ugly. There we go. That's a little bit better. All right, let's put this number line. Copy and paste. Put it right there. And let's put some numbers in here. It says x is less than 5. So I'm going to be going to the left. So I'm going to start here and just put a few numbers here. I'm going to go to the left of 5. I could put a 5 right here, but I always like to put one number to either side at least. Okay, so I'm going to go to the left, so I'm going to count down. 3, 2. And again, you don't have to put a 0 there, but I like to put at least 4 or 5 different points there. And I try to put one to the right or one to the left. You don't have to. You could have put this as a 5. It's perfectly fine. All right, let's just grab that blue. And so it's x than. Now look at this. This is a little different. This is less than. It's got a little line under it, which means it could be equal to. I want to find all the numbers. I want to show on this graph all the numbers that are less than or equal to 5. I don't know if you hear that squealing in the background, but it's like I think it's that bus. I got my window open in my classroom, and that bus brakes are squealing when it's trying to slow down. So anyway, that's what that noise was. So x is less than or equal to 5. So it's or equal to. So if it's or equal to, you always fill it in. All right, so there's a big, big difference between that. So if I want to find all the numbers that are less than or equal to 5, 5 has to be included. 5 has to be one of those numbers because it could be equal to 5. And it has to be all the numbers that are less than 5. So I don't just put in circles at 4, 3, 2, 1. All the numbers in between these whole numbers, count as numbers as well. They're all real numbers. All right, so I can count all those numbers as well. So I circle it in, and then I just kind of shade it in. I just do a little squiggle thing right here, and then I put a big thick arrow just to show. All right, so you just kind of darken it in. Just make sure it's really thick so you can tell the difference between this blue and the white right there. Obviously, you're going to be using pencil, so you won't be able to do color coded, but you want to be able to definitely see the difference between your shaded in stuff and your line right there. All right. So that's x is less than or equal to 5. That's graphing. We're going to do a lot more complicated graphing than this. This is about the easiest graphing that we're going to do, but that's what we're doing today. All right, let's talk about something else that has to do with a number line as well. Let's see. Let's go to this nice orange color. And that's called absolute value. I'm sure you've heard of this before. A lot of people get confused on it, but it's really not that difficult if you understand the definition to absolute value. Basically, absolute value is just the distance, okay, it's how far something is, the distance between 2 points. I guess there's probably more formal definitions than this. Maybe in the book they give some fancy definition, but this is basically what we want to talk about. It's the distance between 2 points. Let's say you're going down the road and you hit a mile marker 10. So let's put that graph on here again. We'll use this as an indication for our road. Okay, and let's say you're over here. Let's say you're going this way from left to right. All right, so, well, let's do it like this. I'm sorry. Let's stay consistent with putting the bigger numbers to the right. So let's say that's the 10-mile marker, and let's say this is the 3-mile marker, okay? And you want to find the distance, okay? So you're driving along, you hit the 3-mile marker, and our destination is at the 10-mile marker. And you want to find out how many more miles do I have to go? Well, that's the distance. That's how far you go, all right? So if I'm cruising, here's my car. Check out my cool car. Tell I am not an artist. So that's my cool car. Looks like a spaceship or something, rocket ship on wheels. All right, so there's my car, and I'm going in this direction. All right, and I hit the 3-mile marker, and then you ask your parents, am I there yet? Are we there yet? Are we there yet? So your parents say, yeah, we're almost there. You got to get to the 10-mile marker. So you got to figure out the math. Well, that's pretty easy. If I'm at 3 and I got to get to 10, basically what do? You just subtract, right? You just subtract those two numbers. So 10 minus 3 is 7. So the distance between those 2 points is 7. What if you're going the other way, right? What if, looks like your car jumped the road. I don't know why I didn't put it right on there. Anyway, let's say your car is going this way and you're cruising down the road. Let's say you're going north this way and you're going south this way. So you cruise and you hit the 10-mile mark and you're like, well, how far do I have to go to get to my destination? Your destination is right here at the 3-mile mark. Well, you would subtract again. Okay, you could go 10 minus 7, but you could also go 3 minus 10, right? But if I go 3 minus 10, what's 3 minus 10? Well, 3 minus 10 is negative 7. Would you tell somebody, well, I've got negative 7 miles to go? No, of course not. You would never say that. You would never say, I would go negative 7. You just say 7. So distance is always measured in positive numbers. It doesn't matter how you subtracted it. You could have gone 10 minus 3, and that equals 7, or you could have gone 3 minus 10. Even though that equals negative 7, the 7 is our distance, okay? The negative just basically tells you what direction that you're going. But absolute value has a little symbol. So instead of 3 minus 10, just like that, they put it with these 2 bars on the end. What that does, that makes you realize that you're finding the distance between those 2 numbers. If I got 2 numbers, I subtract the 2 numbers. So I'm going to keep this in absolute value right there. Now, what absolute value does, it's asking what is the distance between those 2 numbers. And you would tell me it's just 7, not negative 7. So I'm just going to make it a 7. So basically, it's a weird looking 7. Let's try that again. That's better. So basically, what the absolute value does, it just takes what's ever inside of here and it turns it into a positive number. You're finding the distance between those 2 points, okay? That does not mean, this is what a lot of people get confused about. Some people will do this. Some people say, oh, absolute value means everything's positive, so I'm just going to turn that into a positive. 3 plus 10 is 13. No, that's not the distance between mile marker 10 and mile marker 3, right? So you can't do that. That is not correct. What you do is you do all the work inside the absolute value first. So it doesn't matter if there's negative numbers in there. It doesn't matter what you're doing. You do the work inside the absolute value first, come up with one answer. If it's negative, the absolute value of a negative number is always a positive number. Okay, an absolute value, watch this. What if I had, like that top one right here, what if I had the absolute value of positive 7? It doesn't mean you necessarily take the opposite of it. A lot of students get confused on that. A lot of people think, oh, absolute value, I just take the opposite. No, you only take the opposite if it's a negative number. Absolute value means whatever's inside the absolute value is always positive, all right? So whatever's inside the absolute value is always positive. So the absolute value of negative 7 is equal to 7. The absolute value of positive 7 is equal to 7. So that's what absolute value is. So let's do couple more examples. Oh, I keep scooting it over like that. All right, let's do a couple more examples and we will be finished. So let's use the number line one more time. And let's put some stuff on here. I think this example goes from negative 5 and it goes up to positive 7. So let's see if I can fit those in there. So that'd be negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7. Yeah, perfect. Look at that. All right, so let's put those numbers in there. 2, negative 1, 0, 1, 2, 3, 4, 5, 6, and 7. Okay, we got our numbers in here. So now let's go to, we're going to have announcements here in a second. I can't pause my recording. I can only stop it. So we're going to have to sit and listen to the announcements, and we'll listen to the pledge and all that good stuff if they do that today. All right, so bear with me, and let's listen to this.
Please rise for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. You may be seated. Please join me in prayer this morning. Father God, we praise you for this day, Lord. We thank you for the many blessings that you have planned for us today. And I pray that you will allow us to recognize them, Father, that we will look for them. Father, I pray that you will use us today to glorify you. Thank you for all that you've given us and your many blessings. I pray in Jesus' name. Amen. Okay, several announcements this morning. Just a reminder to both students and teachers, everyone needs to be wearing masks while they're in the building, except when you're eating. So make sure you're doing that. Also, tomorrow, Friday, we have a new dismissal. On the calendar, it says that we have Grandparents' Day. We do not have Grandparents' Day tomorrow. Just a new dismissal, but we will be having a prayer convocation and a pep rally tomorrow. And that will, weather permitting, is going to be down in the stadium field. And that will be at 10 o'clock. But make sure that you just wait, teachers, before you dismiss the students to go there and wait for a dismissal announcement. Tomorrow's schedule will be a regular schedule. We'll start the day with periods 1, 2, and 3 before we go to the prayer convocation. As far as sports are concerned, there are no games today. However, on Saturday, there was supposed to be a game on Friday, a big football game against St. Mark's. However, that needed to be moved to Saturday. So it's Saturday at 7:30 in the evening. And the home game is at our stadium. Just so you remember, there's a $5 entrance fee. And we're asking everyone to wear a red shirt in support of our Red Lion team. Also, fans may bring a chair or a blanket. We expect a full house in the stadium. So if you either just want to sit on the hill outside the Fusey Center, you may do that. Bring a chair or a blanket. In some cases, we may have to not admit anybody else in the stadium because it's full. So you may want to sit there. So you just may, if you get here early, the stadium opens at 5. And so if you get here early, you're probably going to see the stadium. But otherwise, you may want to, just in case, plan to bring a blanket or a chair just in case you can't get in. But it's going to be an exciting game, so please come out and support the team. Tonight, there is going to be a parent back-to-school open house at 6:30, so encourage your parents to attend. Thank you.
All right. Good announcements. So come out to the football game if you're watching or listening to this before Saturday. All right, and Q is at 7. All right, here's a couple questions that they may ask you to find. I think there's going to be 2 questions, at least on this example anyway. It'll say find the distance between, I'll just put between P and Q. P and Q. All right, so there's P right there, and there's Q right there. We want to find how far it is between those 2 points. Well, you've got coordinates. Let's put a dot right there just so we can see it. Okay, there's -5 at P, and there's +7 at Q. So how do we do this? Find the distance. What's distance? It's absolute value. So I'm going to put a little absolute value. And how do I find the distance? I always subtract. Remember the 10 minus 3? We always subtract to find the distance between 2 points. And it doesn't matter the order that you subtract. Let's just go the left one minus the right one just to see. And do it both ways just to show you that it doesn't matter. So I could go -5 minus 7. I put it in absolute value. Why do I do that? Because I'm trying to find the distance between -5 and +7. I put a subtract in the middle. So let's do the math here. My little rule is for subtraction, I always say add the opposite. So they're the same signs. When you add, it's -12. But again, it's in absolute value. So if I asked you the distance between 2 points, you would not tell me a negative number. You would always give me a positive number, and that's what the absolute value is. And that's +12. And that's the answer. It says find the distance between P, Q. Sometimes you'll see this. You'll just see a P and a Q equals, and then, I don't know, maybe a question mark or something like that. Or it might say find PQ. All right? It might say something like that. That means the same thing as this. This is just all written out because we first started doing it. But sometimes they'll do this. They'll just say find, and then they'll put a P, capital P, and a capital Q next to each other. No line over top of it or anything. That means to find the distance between those 2 points. And that's what you would do. So on your homework, what you do on your homework is you write out the question, you show your steps, even though it might be easy and you can do this in your head, you show your steps, all right? You keep going, you show another step, and then you show an answer and you circle your answer. That's how I want you to do your homework problems, okay? So that's that. Let's do one more and we'll be done. Oops, oh my goodness, what was that? Let's try that. That's better. All right, so the same thing. It says find the distance between Q and R. So instead of me writing out the words find the distance between, I'm just going to say find QR. Again, that means right there when you have the 2 capital letters next to each other, it means find the distance between those 2 points, Q and R. Oh, I said I was going to do this 2 different ways, didn't I? So let's do that. Instead of going -5 minus 7, you could have done it like this. So here's an alternative. So or, you could have, again, finding the distance, absolute value, you could have gone 7 minus -5. It's not 7 minus 5, it's 7 minus -5 because we're finding the distance from here all the way to here. So if we do the math on that, 7 minus 5, again, we add the opposite. It's just 7 plus 5, which is 12. It's supposed to be an equal sign. All right, get a little sloppy here. I'm on the edge of my graphics tablet here. So what's the absolute value of +12? Is just +12. The absolute value always comes out to positive. All right, let's do QR now. So QR. Q is 7, R is -3. You do the same exact thing as we did up here. So instead, we put a -3. So let's go -3 minus 7. If you like doing it that way, left to right, that's fine. You can go right to left. It doesn't make any difference. Add the opposite right there. That's a -10, but it's in absolute value. So our answer is 10. You could have done it the other way. You could have gone 7 minus -3. It's the same exact thing. 7 minus -3. Add the opposite. 7 plus 3 is 10. And your answer is 10. So either way you do it, you get the same answer. And that's it. That's it for absolute value. And we're good to go. Let me do this. The homework that I gave. Now, I don't know if I went far enough, but this is what I gave in class, just so you know what I said in class. So it would be, so here's how you would write your homework down. It's supposed to be an E section. This is R2. And this is part 1, so I'm just going to put part 1. And let's see, it's page 27. So it's page 27, numbers 39 to 83, but we're only doing the odds, okay? And these are all really pretty short and simple. It looks like there's a lot, but really it's only like 20 some problems, okay? So it's not that big of a deal. So that's your homework right there. We'll continue with part 2 actually today in class. I have a free period right now, and then I'm going to go to class and we're going to do this again, and we'll do the part 2. All right, well, that's enough of that, and I hope you enjoyed it, and we'll see you later.